everyone. My group is E493. Our task was to design a river sewage system for 10 eco houses to give marine sewage system. My partner Domingo will now continue with the presentation.
Objective. The objective is to protect. The objective of the project is to carry away and treat wastewater for 10 eco houses. First thing is to carry away, take out the wastewater out of the house and take it out to the septic tank. Second part is to treat. Septic tank is out there for do primary treatment, and afterwards is taking the wastewater out for to the lagoon. Next, concept one.
Concept one was ocean dumping. The concept was not conceived fully because it was technically complex construction, because we needed a 4-mile long tube to take the wastewater to the sea. That was to be in accordance with environmental laws. So the cost was very high. 4 miles of PVC tubing is expensive. It was lowly sustainable because we are adding mass to the sea and we don't know fully what could be the effect, if it was good or bad. So it wasn't sustainable. It does not agree with the trends on wastewater treatment. The new trends are on-site wastewater treatment and not to affect nature. Also, pumping was required. This brings the problem of energy consumption and the reliability of the pumps. So now we're going to continue with the second concept.
Second concept. Hazard can rise to groundwater. You got to be careful with the underground water. Also, it's very popular in the U.S. Not so down over here. Soil tile limitations. You got to be careful with the kind of soil you're dealing with, because by any chance you're dealing with any soil, it's going to be stopped. Also, you got to use a lot of PVC piping. I mean, for one house, you got to do a lot. Imagine for 10 eco houses, I mean, you got to actually rebuild, multiply the same amount that you have for one house, you got to multiply by 10. So it's a lot of material you got to use over there. Next concept. This was the last concept that we actually did. It's highly reliable. I mean, you're using gravity, no pumps required. Plants and bacteria are the ones that are required, the ones that break down the material and take down the effluent to the standards of EPA. Less material is required, so we don't have to use PVC piping that much. Only we use PVC piping only from the houses down to the septic tank and to the lagoons. It's highly sustainable. It's very non-likely that plants are going to break down or the septic tank is going to break down. Flexible construction methods. I mean, you can use the lagoons to make a landscape. This also makes a habitat for plants and animals. And it's also very cheap out of the three.
Well, the analysis highlights. We're going to only focus on what we think was the most important part of the analysis. First, the reliability. We're using PVC pipes that are construction standard for more than 20 years, so it's known to be a really reliable tubing if used on the right schedule. We're going to put register openings wherever the fluid changes direction. This is when we have a clog, we can access it fast and the system can keep on operating without many problems. The lagoons are twice as big as they are needed, so in case we have more water than expected, for example, hurricanes, heavy rains, we can manage it. The lagoons also will be fenced and will have hazard signs to prevent that anyone is throwing trash or chemicals into the lagoons, or a kid comes running and gets in the lagoon and we have problems of social reliability.
Process safety. Bacteria is going to be the one doing the principal breakdown, the primary treatment. Also plants afterwards. Surface evaporation. The sun over here is very high. I mean, the sun over here is going to be the one doing mostly of the evaporation for the effluent water in the lagoons. And on the water, underground water is safe. I mean, we chose a proper site and sightings. I mean, you gotta be careful with that one too. Sustainability. We created a new habitat. I mean, right now with the destruction of our ecosystems, I mean, we also we're building our we're taking down mountains, we're taking down forests and everything else, and we're actually, I mean, we're taking out a small piece of the habitat so we can actually live on it, and we're trying to give some back with the concept of even, making a lagoon and making a new habitat for the plants and animals. Also, zero energy, I mean, we're using the landscape, we're using gravity to actually carry away the water. Little resources used. We're using less PVC piping of the other systems and less equipment like the pump and energy. It's an EPA approved method and it's used in many countries like India, New England, and United States also.
Well, the life cycle cost analysis. Everything is always translated to money. So we took the capital cost of the construction. We roughly estimate at $50,000, and with a very aggressive maintenance that includes a plumber going every week to check the system, landscaping, all that stuff, $7,000 per year, and the salvage value of the system, thinking that we can recycle maybe the plants, some landscaping, and the PVC, we estimate at $5,000. So if we take everything that from the future back to our present time, it will be an investment of $1,000, $11,000. This is the current method used to calculate how much it's going to cost over time.
Conclusions. The circle goes back around. I mean, simpler goes better. Not always, and size does matter. I mean, what we're trying to say here is that if you have a system that works maybe for 10,000 units of houses, maybe it's not so sure it's going to work with 10 units of houses. So, I mean, sometimes you got to go back around, sit down at the table, and actually rehearse and rethink what you were thinking in the first place. So,
also, the cycle goes round means that 100 years ago, nature did the job of cleaning up waste. So we're going back to nature, and also size does matter. We saw it with the ocean dumping. It's good for maybe 10,000 houses, but to downsize it for 10 houses, it didn't work for us. So we go with the simplest, so it's better. Thank you.
okay.